Hey guys, so now let's talk about how to divide numbers that are in scientific notation. So usually when you see a problem with division with scientific notation, it's going to look like a fraction. We know that the fraction bar represents division. So there is the possibility that you could see this same problem written like this. But most of the time, you're going to see it written in this fraction form. So when I do this example, I'm going to leave it in the fraction form so that you can see that, because that's what you're normally going to see. So this is very simple, just like the multiplication version, because it's actually maybe even more simple, because when you look at it, you have your coefficients kind of lined up with each other in the fraction already. And then you also have your powers of 10 lined up with each other. So when you do the simplified version of this, you're literally going to bring down the base with an exponent here. And then you're going to bring down the coefficient that's the result of dividing the two numbers that you were given. So, let's start with the bases. We know that this is the same base. We've got a base 10 and a base 10. So when there's division happening between the same base, I know that I can add the exponents. We've been doing that for a little while. So since this means division, I'm going to subtract the exponents. Here's the part where, especially when you have a negative exponent, I want you to actually think about this like this expression, or actually say it out loud to yourself, where you're saying 4 minus, because you know there's division happening, a -5. So 4 minus a -5. We know that if we take something away that is negative, if I take away a negative, that actually moves me in a positive direction from wherever I had started. So in this expression, I'm starting at 4. Think of this as motion. I took away something negative, which my silly thing that I always say is, if I take away a negative influence from your life moves in a positive direction. So we're actually thinking to ourselves, 4 started at 4, and now my life is moving in a positive 5 direction. That actually gives me positive 9. If you are stuck on that taking away a negative thing, I would suggest looking up a different video about that. But we are going to continue trekking on, because that's not the main goal of this video. So again, 4 minus -5. That's a terrible -5. -5 equals a positive 9. So I'm going to keep the base of 10 that came from right here. And then this is going to be 10 to the power of 9. I got that from doing 4 minus -5. Then I just need to grab my calculator, because nobody has time to do this in their head. And I'm telling you that it's okay to do this right now. Then I'm going to do 8.31. My pen is not working. 8.31 divided by 7.9. So I'm throwing that in my calculator, and I get 1.05, and then a lot of digits after that 5. I'm just going to leave it as 1.05, because that's probably the furthest decimal place you're going to be asked to provide when you're giving these answers. So 8.31 divided by 7.9 gave me 1.05, and I rounded to the nearest hundredth and didn't do all the digits that came after it. And then, as long as this number is correctly in scientific notation, then I'm good. Remember that this first number at the front of the scientific notation, currently highlighted in yellow, that number, the coefficient, has to be greater than 1 but less than 10. So when I'm looking at this number, it passes the test. This number is greater than 1, 1.05, and it's less than 10. So as long as that is the case, you know that you're good, and you have your final answer. So for this particular problem, the final answer to this original thing would be 1.05 times 10 to the 9th power. Let's look at one other example, maybe where we don't get the exact final, like our coefficient is not in the correct form, where we are going to maybe have to modify something there. So let's look at 5.65 times 10 to the 6th and 7.5 times 10 to the negative 2. Again, same thing. I'm going to take these guys, divide 5.65 by 7.5, and then I use my exponent powers with my power of 10 over here. So I'm going to just go ahead and bring down that. Again, this is, you're thinking in your head, 6 minus negative 2. Okay, and you know that when you have a negative being taken away from something, we move in a positive direction. So that's going to actually give me a positive 8. And then I'm throwing in 5.65 divided by 7.5 into my calculator. So here's where we're going to have an extra step that we didn't have in that last problem. So this is the number that I got when I did 5.65 divided by 7.5. I know that this cannot stay like this because that number is not greater than 1 and less than 10. So I need to plop the decimal into a place that is actually going to make that number greater than 1, less than 10. So I know that the decimal place needs to be right here, but I can't just keep the power of 10, the 10 to the 8th power. That's not going to be the exact same number if I just leave it. Those are two separate numbers. So I'm going to come over here. This is just big old thought bubble down here. This is what's happening for me to figure out what power of 10 I need in my final answer. I know that my original number was this. And then if I'm doing times 10 to the 8th, I know that that's going to make this number bigger. So I'm thinking 1, 2, 3, 4, 5, 6, 7, 8. So I'm thinking to myself, this is where the decimal would end up in giving me all of these placeholders, zeros, right here. So if this was the final, like, resting place, is kind of what I like to think. If this was the final resting place for the decimal, right? And I got that again from this result. Now I'm putting my decimal right here because I know in my final answer, right, I have to have my decimal right here so that the coefficient is greater than 1, less than 10. So now I just need to think to myself, okay, so if my decimal point is landing here, how many spaces is that shifting to get to my target number or the actual number that is represented by the answer that I got here? So you can tell that it's one less shift, right? Because of this situation. There's one less shift happening. So it's going to be only shifted 7 place values. So that's how I know that it's going to be 10 to the 7th because I shifted one less space to get from this number to my target number, which is this giant number. That's a lot of me saying like shift and like going back and forth between different things. I'm intentionally not telling you a rule for, well, if you're moving to the right, you're going up a exponent. If you're moving, like, I'm intentionally doing that because I want you to think about what's actually happening with the place values of 10. I am going to do another video that talks more about shifting place values and the decimal point and how it affects the exponent. So take a look at that when it is released. But for now, that is how we divide two numbers that are in scientific notation. This number right here would be your final answer for that problem.